995 minimum number of k consecutive bit flips. This Java code uses a sliding window approach. Explanation 1. It avoids using an additional array for tracking flips, instead using the input array itself to mark flipped subarrays. 2. It uses a single pass through the array, making it more efficient. 3. The time complexity is O(n), where n is the length of the input array. 4. The space complexity is O1, as it modifies the input array in place. Key points of the algorithm. 1. We use flip count to keep track of the current flip state. 2. When we encounter a number that needs to be flipped, i.e. when flip count equals nums I, we mark it by adding 2 to its value. This allows us to distinguish between original and flipped values. 3. We use the sliding window technique to update the flip count as we move through the array. 4. If we need to flip a subarray that extends beyond the array's length, we return -1 as it's impossible to flip all elements to 1. In summary, this Java code takes an array of binary integers nums and an integer k. The method returns the minimum number of k-bit flips required to make all elements in the array nums equal to 1. If it's not possible, it returns -1. The method uses a greedy approach with a sliding window technique and in-place modification of the array to track flips and ensure efficient computation.